Hey guys, welcome to Section 6, Chapter 7 of the Algebra 1 program entitled Systems of Linear Inequalities. So now we're going to put the entire chapter together, and now we are going to find the solution set for a pair of linear inequalities. And the solution set is going to be a shaded region. Just like we learned yesterday that when we graphed linear inequalities, the solution is a shaded region. Now our system of linear inequalities is also going to be a shaded region. So we're going to go slow. We're going to do several examples, but hopefully you'll be able to put all these pieces together and do just fine. All right, so let's start. What if we had the inequality y less than or equal to 5x plus 1 and the inequality y greater than x minus 3? Okay, so both of these are solved for y, which means starting my graphing process is easy and straightforward. Of course, I'll start with the top. So for the first inequality, I'm going to start at 1 on my y-axis, and then, of course, my slope is 5. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. Maybe we can go down 1, 2, 3, 4, 5, and over 1. All right, and now my first big question is this line going to be a solid or a dotted line? And because of that equal to sign we learned yesterday, this thing should be a solid line. All right. All right, now I want the values that are y less than. All right, with these really steep ones, right, sometimes it's hard to tell. So before we start to shade, I want you to do the test point. Let's test 0, 0 and plug that in. 0 less than or equal to 5 times 0 plus 1. 0 less than or equal to 0 plus 1, and 0 is less than or equal to 1. Is that true? Yes. Okay. So hopefully if you were tempted to shade on this side, then you would have done that and been correct. So that is underneath there. Okay. So let's start with the second inequality then. All right. For this one, maybe I'll choose a different color pen here. So we start at -3, 1, 2, 3, and this has a positive slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1. You can go on forever if you'd like. Is this going to be a dotted or a solid line? Say it out loud with me now. All right, this one should be a dotted line, because it is not equal to, it is strictly greater than. Okay, so then the question begs, let me use a blue highlighter here. These values are going to go above. Now, how do we determine what the solution is? Well, the solution is going to be the point of intersection. So where do these things overlap? They overlap right through here. And that is what we're looking for. So when you graph these, again, this would be a time to use multiple colors. It might help you organize the information, but make sure you really emphasize where that solution is. So what we're saying is that if you pick any point inside this dark purple, that point is going to make both inequalities true. Okay, let's keep moving on here. Let's do another example. What if we have the inequality y greater than 4x plus 3, and then y greater than or equal to -2x minus 1. Here's my first inequality, and here's my second. Okay, both are solved for y. My life is happy. So let's get going. We grab the first one. We're going to start at 3. 1, 2, 3. And then we have a slope of 4. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. Just do as many dots as you feel like you need to get a good line here. All right, dotted or solid line, folks. What do you think? Dotted. Dotted because it's not equal to. All right. Oops, I hit my button. Go back to my purple. Now, is this going to be shaded above or below? It's y greater than, so it's going to be over here. Again, if you're not sure, you can test that point. Test 0, 0. In this case, 0, 0 should not work, right? I know it's close, but 0, 0 is right here, and it shouldn't be in our solution set. Okay, let's go with our second inequality. We're going to start at -1 now. And now I have a slope of -2. So I'm going to go up 2 into the left 1, 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 maybe down 2 and over 1. All right, now is this one going to be dotted or solid? Hopefully. You see solid there. It's equal to. All right. And then the question is, where do we shade? Oh no, I did that blue. So this is also y greater than, which would cause me to shade over here. And then look at that, it even changed colors for me. That's fun. Where's my point of intersection? It's going to be right through here. That's what we're looking for. All right. You guys doing great? I'm sure you're doing great. Let's do another one. What if we have y greater than -x plus 2 and y greater than x minus 4? Let's see how these do. All right, I'll start with the first one. That's going to start me on 2. With a negative slope here of 1. So up 1 over 1, up 1 over 1, up 1 over 1. Or down 1 to the right, down 1 and to the right. This is going to be a dotted line. Strictly greater than. All right, let's grab a purple highlighter. And this is going to be y greater than this value. So greater than denotes above the line. Again, we can check a point. Maybe for this one, we'll grab a point of intersection. We'll see. All right. Now my second inequality here, it's going to start me at -4. And my slope is a positive 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1. Ooh, oops. That one didn't go. How about there? And then down 1. Over 1, down 1 over 1. I used a new graph and I feel like it's a little bit harder to read for me. All right, is this going to be a solid or a dotted line? Hopefully you're getting that part, and it's going to be a dotted line. All right, let's grab another highlighter. Now, this is also y greater than. Y greater than is going to shade above the line. Of course, because this thing is awesome, you're going to be able to see this point of intersection here. Let me get my dark color though. So all of this where that shading is going to intersect is going to make us very happy. All right, let's do a check here. I've been telling you that a point inside the combined shaded region is going to be a solution, but maybe you don't believe me. Okay, so let's check the point. It looks like 3, 3 is in my solution set. So it should make both equations true. Let's try the first one. 3 greater than negative 3 plus 2. That's going to be 3 greater than negative 1. That's a true statement. What about point 2? 3 greater than 3 minus 4. 3 greater than negative 1. Also true. All right, so let's try one more, and hopefully you guys are going to be ready to go here. What if we have y less than or equal to 5 and y greater than or equal to negative x plus 1? All right, sometimes the easier ones seem to be more confusing. Like, how do we graph y less than or equal to 5? All right, well, first of all, we look at our y-axis, and we're going to find the point number 5. And now, this line is the straight line that goes right through that point. And it's going to be a solid line because it's y less than or equal to 5. All right, where's my purple? Oops. I'm going to pick that one. There we go. Okay. Now let's try our second one. I'm going to start at 1. And now my slope is negative 1. So I go up and to the left, up and to the left, up and to the left, up and to the left. This is also going to be a solid line because of the equal to. Get a different highlighter. All right, and this is y greater than. So you're going to start to see the piece of intersection here. Okay, so now I'm going to get my darker highlighter, and I'm going to intercept these two spaces here. And you're going to see the solution set is that darker shaded region. Okay, that's all there is to the homework. So just take your time. Make sure that you're watching whether it's a dotted or a solid line. I don't think there's too many where you actually have to solve for y for these. So this is just a lot of practice with the graphing. If you've not yet invested in graph paper, that would be a great idea. And if you have some colored pencils, they would really come in handy today too, I think. So if you guys are ready, go ahead and finish up your notes, read through the section, and begin your assignment.